In this lesson, you will memorize terms relating to pyramids, as well as calculate the lateral area, total area, and volume of a pyramid. Now with pyramids, there are multiple terms that you need to know. The first term is what we call a vertex. The vertex is the peak of the pyramid at that point right there. Next we have the base, which is the bottom of the pyramid. And then we have the altitude, which is the perpendicular line from the vertex to the base. So that line right there would be your altitude. And it's perpendicular, meaning it forms a right angle. Next we have height, which is the length of that altitude. And then we have the lateral face, which are the faces that are not the base. So every triangle you see there, here in the side, the front, other side, and the back, those would all be your lateral faces. Next we have the slant height, which is the height that is slanted, or the distance measured along the lateral face from the base to the vertex. So this line right here, the slanted height, the height of the slanted triangle, would be your slant height. And notice that it's different than the actual height. Height is perpendicular to the vertex, whereas a slant height is perpendicular to this side down here, to this triangle on the side. And we use the letter L for slant height and the letter H for just regular height. And next we have the lateral edge, which is where the faces meet. So these lines here in red, it's kind of hard to see, but each of these lines going from the vertex down to the corner would be each a lateral edge. Next we have what is called a regular pyramid, which are pyramids that have a regular polygon as the base. So here are a couple examples of regular pyramids. And remember, regular polygon is a polygon that has the same side length and has the same angle measures on the inside. So each of these would have a regular polygon at the bottom. Now let's work with using those terms to find lateral area, total area, and volume. The lateral area is the area of all the triangular faces. And so we know one triangle we find by taking 1/2 times the base of the triangle times the height. Now notice there are 4 triangles here in this picture. And if we look at the base of this front triangle, we have this segment right there. The base of this other triangle would be right here. The base of the back triangle is right there. And the base of the triangle on the left would be right here. Now, if we wanted to add all of the area of the triangles together at one time, I'm going to incorporate all of these bases together at one time as well. So what I do is use this formula, 1/2 base height, but I'm adding up all the bases. So instead of a base, just one base, I'm going to have the perimeter of the big base. So if I add up all these bases together of the triangles, I have the perimeter of that square. So instead of the B, the base, I'm going to put in a P for perimeter of the base. And then the height of the triangle would actually be the slanted height, because the triangles are all slanted. So instead of height, we're going to have slanted height. So the formula to find the lateral area is 1/2 of the perimeter of the base, and then multiply that by the slant height. So here's an example. We have the height being 4, the slant height is 5, and then the distance from the center to this outside is 3. So to find the lateral area, I take 1/2 times the perimeter times the slant height. Well, the slant height in this case is the 5. So the slant height is 5 right here. And then the perimeter of the base, we need to find just one side length. So notice from here to here is 3. And by the way, the vertex will create an altitude that goes to the center of the square. Meaning if this is 3, then all the way across would be another 3 here, which would make that 6. So the altitude will bisect or go to the center of this square. So this is 3, that's 3, the entire length is 6, and this is a regular pyramid, meaning every side length is the same. So this is also 6, that is 6, and then back here is 6. So the perimeter would be 4 6s put together, or 4 times 6, which gives me 24. So I plug a 24 and a 5 in, and I'm going to get 12 times 5, which gives me 60 square inches. And then total area is the area of everything. So we have the lateral area, then we need to add in the base. So adding in the base is going to be a square, and the square is 6 by 6, so 6 times 6 would give me an area of the base of 36. So the total area would be 60 plus 36, which would be 96 square inches. Now the volume of a pyramid is related to the volume of a prism, where if you can imagine a prism with this exact base and this exact height, then the volume of this pyramid would be 1/3 of that volume. So the volume of a prism was area of the base times the height. The volume of a pyramid is 1/3 of that. So 1/3 area of the base times the height. And the area of the base we already found, because if this is 3 right here, then this would also be 3, which makes the entire length 6. So the area of that base is the area of the square, which would be 6 times 6, which would be 36. So 36 would be the area of the base, and then multiply that by the height, which is 4. So now we have 36 times 4 times 1/3, which would give me 48. So the volume of this pyramid would be 48. Now there may be times, such as in this picture, when I don't know or I need to find the base edge and lateral edge. So the lateral edge, remember, are the edges going from the vertex down to the corner. It's where the lateral faces meet. The base edge would be down here at the bottom. So like this length or this length would be the base edges. So in this case, starting with the base edge, what I can do is use the fact that this length right here is going to be half of the entire length across. So if I can find this length right here, then I can find the entire way across, which I can then use later if I wanted to find the total area as well as the volume. So here, if I just use Pythagorean theorem, I have 6 squared plus b squared equals 10 squared. So this is a right triangle, 10 is your hypotenuse. I plug those numbers in, we get 36 plus b squared equals 100. We can solve for b by subtracting 36 from both sides. So now we have b squared equals 64. Take the square root of both sides, we have b equals the square root of 64, which gives me 8. So this length is 8, which means the entire base edge would be 16. And then the lateral edge, we can find that as well. And this one is kind of difficult to visualize sometimes, but the lateral edge would be this segment right here. Now if I look at this triangle, where I have this side and then the slanted height right here, looking at this triangle, this would be a right angle right there, because the slant height creates a right angle on that side. And then we know that this length is 8, which means that this length would also be 8, because this is also halfway across this side. So if that's 8, this is also 8. And notice we have a right triangle, where the lateral edge is your hypotenuse. And so I can solve this by using Pythagorean theorem again, where now I have 8 squared plus 10 squared equals c squared. And that would give me 64 plus 100, which would be 164. Take the square root of both sides, I get c equaling the square root of 164. And if I take the square root, I would get 12.8 for the length of that lateral edge. So if you don't know the lateral edge or the base edge, you can use Pythagorean theorem to solve, and then from there you can use that if needed to find lateral area, total area, or volume. And that concludes our lesson for today. We will see you next time.